So sound transmission class. Why don't SIPs necessarily act really well in sound? They do. They work great in sound when sound is carried on air, which is where the vast majority of sound goes through wall assemblies, is on air, the cracks and the leaks in your assembly. Why then do they not have great numbers? They don't have great numbers because when we test walls for sound, we test them in 4 areas. Frequency and energy. It's a chart. Low frequency, low energy, low frequency, high energy, high frequency, low. Yeah, 4 corners, right? STC numbers are a makeup of those 4 areas of testing. In a SIP assembly, it works really well all the way until you get to high energy, high energy, low frequency. Think of the car driving by with the thumping sound that's high energy, low frequency that you can feel the thump in your chest. It's very similar to contact sound because it's very close to that energy and low frequency, which is the contact on the diaphragm, and because a SIP is a diaphragm in that it is a composite structure, when the sound hits it, it transmits through. People that live in SIP houses will often say it's the quietest house they've ever lived in, not because it's got a great STC number, because it doesn't, because of that contact sound issue, but because it's very airtight and therefore the majority of the sounds don't get through. Okay? If we're worried about sound, we often add mass. And when we do add that mass, we want to disassociate that mass from the SIP by virtue of the hi-hat channel or the standoffs or something that don't allow then, a big thick concrete skin to be attached to it for mass, and it's still in contact with the SIP, right? We still have that same problem. It's still a composite solid structure. So we want to disassociate that. That's my diatribe on STC. Did that answer the question that was going around the room earlier? Good, I hope. Thanks you. All right, moving on. Installation basics. What I'm going to talk about is where I left off and kind of jump around as far as things that you should know, need to know, or want to know about putting panels together and things like electrical and pricing and such. So what does it take to install a SIP? Typically it's a pretty small crew. In most cases I'm installing panels with crews of 3 to 4 people. That's it, especially if it's a prefabricated package. If you were to ask me, well, how much panel can you put up in a day, or how long does it take to build a house? I will use the rule of thumb that says throughout the entirety of the project, if the SIP structure has 5,000 square feet of panel, I'll typically put that project up in 5 days. 1,000 square feet per day. Now that doesn't mean I'm going to put up 1,000 square feet every day. My record for putting up the least amount of square feet in a day is 0. And I think my record for the most is close to 20,000 square feet in a day. Okay? Jumbo panels, baby, rock and roll, let's go. Up and away we go, right? It's easy to knock out some square footage. The point being is the crew receives the truck, unloads, organizes, stretches things out. Site management is really important. They prep the panels, the crane or the lift or whatever's coming in to put them up, and then they put the majority of the panels up in 1 or 2 days, and then the last day is the wrap up, the punch out, the sealing, the screwing off, whatever the fixings are a requirement. So that 1,000 square foot per day is kind of over the course of the install, it averages out to about that. Okay? Most installers have most of the tools that are necessary, especially if their package is going to be fully fabricated or RTA. Remember, ready to assemble, meaning that the panels are ready to go. All they need is what? A screw gun to screw the things together and a caulk gun to lay out the mastic, and you're pretty much there. Other than some lifting rigging that's special because most carpenters don't carry the proper rigging in their bag that will lift an 8 by 24 foot roof panel. Okay, so there are some certain things that you need. If you're going to go all in on installation, yeah, you might be investing several $1,000s in some unique tools that are appropriate for working in that industry. Okay? Training. SIPs are pretty easy to learn how to put up and easy to do, but they're also pretty easy to screw up if you don't know what you're doing. Okay? I would suggest that any high performance home needs training because the average old school carpenter who has the the mentality that because they've been framing houses for 30 years, they can do anything. They're the ones that screw it up the worst. Why? Because no carpenter of that age, not all of them, but most of them, don't even know how to spell building science, much less talk intelligently about it. And it's the building science that really gets into the nitty-gritty when you start talking about energy efficient, airtight, high-performing buildings. And if you don't understand the building science that goes in along with that, it's going to come up and it's going to bite you in the butt. It really will. It's just a fact. And these old school framers are the first ones that want to think, oh, I can put it up. I've been building houses for years. And they really do need the training in a minimal amount of way to understand the importance of sealing and air tightness and how to properly detail these panels going forward. Okay, so there are some specialty tools of the trade, not a great deal. Again, we let the folks in the manufacturing take care of those things. How do we lift SIPs? Well, there's really three ways.
Sorry,
question.
What are the most common and worst offender mistakes you see on site that folks need to build in SIP?
There's some great slides coming up for that.
Okay. All right.
Yeah, you've got some, right? Yeah, I have a few. The biggest offense is to not properly seal the panels.
At the joint?
At the joints,
yeah.
Right. If air, especially if you're in a cold climate,
yeah,
that would be probably the biggest mistake. The biggest mistake made by designers and architects and some building owners in the SIP industry is to not understand where a vapor barrier goes, and then to design a house with a non-permeable roof underlayment, like a peel and stick, on top of a SIP panel in a cold climate. Bad juju right there. Okay, why? Because if you do have an air leak, and with that air leak it takes moisture, and that moisture condenses and now becomes liquid water, how does it dry out? We'll talk more about that in a little bit, okay? So, how do we lift panels? There's three ways if you look at this slide, four if you include a helicopter, but they're way too expensive, so I don't use those hardly ever. Typically cranes, forklifts, or by hand. How big is the panel? If you're using blank panels that are only 4x8, can you lift them by hand? Sure you can. Can you tilt up wall panels that are 8x8 or 8x9? Absolutely. I used to do it. I don't anymore. Now I just talk, try to look young. And then the cranes and forklifts are the most common. Forklifts, great option in the field because not only will it unload, but it will set panels perfectly well, and a lot of people have them when they're in that industry.
You got a question?
Question?
Just back to that other slide, just a second where he's Hanson. Is that panel that he's standing on cantilevered out there?
No, that is not. That job is in Southern Virginia, and it's got a, remember we talked about separating your trusses and not going over a standard conventional truss roof? This one, the trusses were spaced at, I believe, 4 feet. Pretty sure that's 4 feet. And then those gang trusses go down and continue on down. That is not cantilevered.
Okay.
Okay? Site management. This is one of the areas where if you're not paying attention, you'll back yourself into a corner, especially with large panels that need to be sorted, need to be prepped and prepared for installation. If you show up to a job site and you've got a huge field around you, great, you're really, really lucky. Try doing a panel package with jumbo panels in the middle of the city. You better have your stuff together or you're going to be in big trouble, right? So site management and the logistics of your order, the delivery, and how you're going to put those panels up takes a little bit more forethought. If you're going to build old school stick framing, conventional framing, I can carry a stack of 2x4s, you know, wherever you need to. But you're not going to do that with an 8x24 foot panel. Question?
The logistics on an infill site, then, what do you see? I mean, what kind of laydown room do you typically got to have to be able to at least maintain some momentum if you're getting the panels in tranches? Because, I mean, I can envision many sites where you don't have enough laydown room to put all the material on site at one time. So
we've done projects in inner cities where the laydown room was the back of the trailer that pulled in at 7 a.m. and you had the panels stacked and oriented in the correct way so that the self-erecting tower crane could pick and set, and set. Right off the trailer. So the answer is as much as you can get, you know, and then you got to look at how many panels do you have, how are they being delivered. I mean, it's just a logistics thing. So it's a different mindset, and it's very, very important that one pay attention to that when you start getting into that game in the field.
yeah, because the practical aspects of having a truck on standby while you're offloading and assembling is really tough.
It can be very difficult, very difficult. And I mean, I've done projects where there was literally hundreds of trucks showing up over a period of a month or two, and you have to make sure that they're coming in exactly when they're supposed to be. So site management is important. Rigging. We can rig panels. Believe it or not, that is a wall panel. Those are small windows, but it is a wall panel. This project went up in Texas. And you will notice if you look at the slide that actually that's about 7 panels, I think. So 7 panels were pre-assembled on the ground, and then we lifted it at one point in time. It's safer to work on the ground. It's easier. I can seal things up. It's not a problem to work on the ground. I like it. And that way, pre-assembly helps me, and this can be done before the crane even shows up, which is why you don't need the crane there the first day maybe. You need it there day 2, and you've pre-assembled and prepared panels for the lifting. We can pre-assemble roof panels and fly in large roof sections. I don't know what the largest roof area section I've lifted in, probably 24 by 24 maybe. So it's a big chunk of panel. We fly the whole thing in, drop it in place, and away we go. So again, with the idea of speed, we really want to think about how we can prepare these panels so we can fly them in as quickly as possible. There's a fairly large panel, okay? You can see them dropping that in. The panel is going up, it's all pre-prepped. Some of the lumber is already installed in the side of those panels. You can see that lumber in the rake edge of that dormer panel. That's actually a dormer roof panel. Getting ready to fly in.
Does that have something for the ceiling underneath, already on it, underneath, or what's it? Or is it just too dark on this?
It's just the darkness of the OSB. It's just the light in that shot. Here's a sequence of panels going in over top of a garage. This is a livable space above a garage. I think it was up in Connecticut. And we're going to flip through it real quick, gable, and we're going to count the number of lifts. Here's the lift number 1, dropping in a gable end. Other gable end goes in, the ridge beam flies in. Now I've got support for my roof panel up at the top. Once that goes in, we're doing some sealing between the walls and the roof panel where that's going to go. And then we start flying roof panels. The roof panels are flying in on a pitch. These are 4-foot wide panels. The panels get closer, we drop them in, we put them in place, attaching them with screws. You can see the blue edge of the wall. This is where there's some sealant. That same sill seal that you can see draped over the ridge beam. Again, a sealant gasket where they're getting sealing to create air tightness. We're flying more panels in. We're on the one side of the roof. Now we come over to the other side of the roof. We're dropping more panels in. One side's done. Here we're coming down the other side. Last panel. You can see that blue foam underneath on the top of the wall where we're getting that sealing. Dropping it down. 5 roof panels either side, 2 gables, one main ridge beam. I think that adds up to 13 panels. This project was prepped. Panels were delivered, prepped in the morning. Crane showed up at noon. By 4:30, we were walking off the job site. We had a sealed, insulated, structurally sound top above a garage.
How much of the roofing system underlayment, if there's any use, can be installed as part of the erection process? Like, as I see you got
They tried that there, and I will say that the report I got back, that was unsuccessful, and they probably wasted their time. They were trying something, and it was like, well, it didn't really work. We should have just put them all up and then started laying out underlayment like you would typically.
Yeah.
Okay, but we're going to talk more about underlayment and cladding and backventilating here in a bit as well. Okay, so that gives you an idea of, you know, how fast can something go up if it's done, thought ahead, prefabricated, got a good crew, they know what they're doing. Question?
How much was the panel prep on? You said there was panel prep on the site before you did the lifts. How much panel prep?
So when we're lifting panels, you can see we got chicken sticks up there, so you know, Carpenter Bob doesn't slide off the roof. There might be pre-drilling of holes. Actually there is. You can see those screws going up the edge of the panel. If you look real closely, it's kind of hard to see from the back row. So the prep could be pre-drilling the panels to insert the screws so that when it does fly into place, the carpenter's literally just grabbing his screw gun and screwing it in place, okay? So those are the kind of prep works that you're doing. You can pre-install lumber down a rake side. Matter of fact, am I not mistaken? There's lumber already installed on the edge of that panel. Pre-installed on the ground, just easier to do. You get in the habit of doing everything you can on the ground, quicker, safer, cheaper, easier. Okay? Question?
For the bridge beam, did that corner or the gable panel have to have structural support for the ridge beam?
It absolutely did. That would be a point load where the point load by design exceeds the capacity of the panel to carry that load. Now panels can carry a significant amount of load. From an axial standpoint, they can carry upwards of comfortably over 2,000 pounds per linear foot. Stick frame construction on average is down in the 1,700 pounds per square foot on an average. So, and it can go a lot higher than that, and we can get more by doubling up the plate, things like that, up on the top. So, but you can exceed it. And where you do exceed it, you run a post down through there. Okay? Other questions?
What's the longevity of the system?
If you were to ask the people that manufacture the glue, and the glue holds the system together, they would tell you that in their modeling, the glue lasts about 5,000 to 7,000 years. But that's just the glue, right? What's going to deteriorate? The wood. Wood deteriorates when it gets wet and it stays wet. If it gets wet, stays wet, it's no longer wood, right? How long have wood buildings survived in the world? A couple of old ones. A couple of old ones out there. How quickly can they deteriorate if they're not designed, detailed, and installed correctly? I've seen problems in wood structures happen the first year it was built. So, you know, if we do everything right, damn sure better outlast its mortgage, obviously. Can it last 100 years? I would like to think yes, that's not a problem. Do we have projects that are coming up on 100 years? Well, we will in another decade or two. Yeah, we've got some projects that were put up in the 30s, I think, late 30s. So yeah, we're getting there. I don't know if I'll still be around to say we've got houses that have been up for 100 years, but yeah, it can be done. Okay? Questions? Electrical. Everybody wants to know how we're going to do electrical. The standard panel and manufacturers in the industry design electrical chases into the core, whether that be a urethane core or an EPS core, such that the electrician has the capacity to move wires through the panel. The installer, if they're doing their job correctly, will be pre-cutting holes in the plate or allowing the chases that are coming through the panels horizontally or vertically so that the electrician can move wires seamlessly. The chase acts no differently than a conduit acts. The vast majority of inspectors who look at electrical inspections treat it as thus, and will say, yep, I can see the wire at this box and over at this box and everywhere else, it's buried in the wall. Have there been electricians that have given us pushback? Absolutely. Have there ever been inspectors that, you know, gave a clean bill of health to everything every time? No, absolutely not. Electrical chases are often run vertically right next to doorways. Why? So that we can come up through the doorway where the switch is and then continue on up for a sconce light or something outside. We can also use vertical chases to get from floor to floor. We'll also use conventionally framed floors for standard wire chases or everything else that runs through our houses. Do I want to put more and more mechanical systems or electrical systems into my exterior walls? No, I don't. I want to put plumbing in my exterior walls? I can, but I don't necessarily want to. If I live anywhere in the north, that's just bad design, right? We don't want to put plumbing in exterior walls. That leads to problems. Can we mix and match and run chases to run plumbing or electrical? Absolutely, we certainly can. We can design that mixed and matched system so that we have the capacity to move those systems through. If we're going to put a hanging floor system in, this rendering shows how a floor system might go together, and then we will have chases cut horizontally into our panels, or we can, in the field, drill chases vertically down into the bottom panel, up into the upper panel, and then when we combine those, we can run wiring along the floor system, go into the first floor wall and go up into the second floor wall. When I get up into the second floor wall, I can go horizontally and out to the plug wherever I want to. We can drill into a panel with a hole saw so that the electrician can fit his fat fingers into that hole and make a turn left, right, vertical, whatever it might be, and then that plug can be put back in the hole and foamed back up so that it's no problem. No fuss, no muss. Or we can just foam it up and call it a day, right? We don't even have to save the plugs if we don't want to. There's methods to allow us to move wiring through SIPs that makes it easy. Now, will you find electricians that go, SIPs, my quote just went up 10%? Absolutely. I've seen it happen time and time again. I've also seen electricians that go, yep, I don't have to drill studs, I don't have to staple wires. And if the installer has done their job because they've been trained and they've labeled, pre-drilled, and made allowance for how the electrician will move through the system, then the electrician can move through as quick or quicker than they will in conventionally framed stud walls. If they don't do their job, then the electrician's going to show up, he's going to break out his chainsaw or his router and go, yeah, got to get this wire from here to here we go. And he starts cutting through the skin. And this, yep, there we go, I got a trough, I can push my wire in and get it where it needs to go. This is not what you want to see, it's preparation. The preparation you might not think of in normal construction is to sit down and think about your electrical layout. Oftentimes in regular stick frame construction, when's the first time the electrician shows up on the job site, right? He's bid the job based on the number of circuits and plugs and switches, and then he shows up on the job site, walks around and starts going, well, all right, I'll put a plug here, I'll put a switch here, I'll put a switch here. You got to move that back to the front end while you're still thinking about how the panels are going to be manufactured in the factory, because the manufacturer is happy to put an electrical chase vertically, horizontally, or anywhere else in the program when they manufacture the panels. So take advantage of the fact that your electrical system can actually be pre-designed and thought about when the panels are being manufactured. Question? Go ahead.
Basically what you're saying is anything where you're going to need access inside a panel can be planned for
Yes.
in the design of the panels.
In reference to chases or cutouts.
Well, we build on slabs, so I don't have the option to go through the exterior for my outside.
No, you would typically in a slab, you would either, the way I typically treat it is I'll typically bury a conduit in my slab to get from critical load source to an area where I perhaps can't easily run wire through interior walls, through soffits or through upper floor systems and back down. I might run a conduit in the slab to get over to that one wall on that far end gable. Other than that, I'd run through interior partitions, and where an interior partition butts my SIP wall, I'll literally go out in that SIP wall into that chase area and then go left or right from there. Okay? We'll often put chases at just the right height for countertops. Where's your countertop? What height do you want? Put it there. Oh, you got to get from there down to the floor, run some vertical chases in the kitchen area, because that makes it easy for your electrician to get up and supply electrical in that area. Outside lights in the corner for exterior lighting, vertical chase, boom. Connects the floor system or lower floor system to that vertical chase, allows the electrician to get in there and come up and put his box on the outside. The one thing you have to be aware of is an electrical chase is a highway for air movement, right? Especially if it's got an exterior outlet. So when those electrical chases go in, somebody's got to think about, have they been sealed properly? And this is one of the questions where I say, you're far better off to think about where you need the chases and just put them where you know you need them. Some manufacturers have a habit of putting in a 44-inch high horizontal chase in all their panels because, I don't know, they want to put a switch somewhere, right? Well, where do all your switches go in your houses? Right next to the door, right? Almost always. So if we just put that vertical chase 6 inches off of the door opening right up here, I got a place to get my switch and go up or down. I don't need 44-inch chase all the way around a room because it's just one more path for air to move around. It's one of those things, would you rather need it and not have it, or have it and not need it, right? Roof venting. When we say venting a roof, we're not talking about venting an attic because per the code, we don't have an attic, right? An attic is inside a vented space inside of an attic or a truss or stuff like that. We have conditioned space all the way up to the top of the roof. So what are we venting? We're back venting the cladding. This is really no different than back ventilating the walls, which in the building science world they call what? Rain screen. Somebody explain to me what it has to do with rain and what it has to do with screen, and I'll tell you back ventilating makes a whole lot more sense to say and think about, in my mind, in my world. I don't know, I'm from West Virginia, I think simple. So back ventilation is something that allows air movement behind the cladding in walls or roof that does a lot of good things for us. In the north, we call it a cold roof versus hot roof, right? I'm more inclined to say it's more about drying, because that's why we want to back ventilate, is to dry. In Minnesota, for those people crazy enough to move there and stay there, they worry about ice damming, and that's why they put cold roofs on, right? Because the cold roof prevents the snow from melting, and snow, it has R value. 1 per inch, same as wood. Snow and wood, same R value. 1 per inch. So when you put 12 inches of snow on your roof and you don't let it melt off, you got R12 more sitting on top of your roof in the middle of the winter time. Ventilate underneath that cladding and it doesn't melt, it stays cold, and therefore it stays up there. That's why we back vent, that's why we call it cold roofs up in the north. But if you've got a solid SIP roof, are we worried about ice damming? Not if it's been installed properly. What are we worried about? We're always worried about moisture. I want to keep moisture out so my house lasts 100 and whatever number of years, right? And back ventilating is very, very important. So I want to do that and keep it dry. A really smart fella who wrote this book came up with this detail, Joe Steebrook. And look at it for just a second and think about it. Every material has moisture capacity. We'll call it safe storage capacity. If we exceed that safe storage capacity by excessive wetting and not enough drying, stuff goes bad, per this drawing, right? So it's all about the rate of wetting and the rate of drying. Joe Steebrook will often say, you do not have a moisture problem unless the rate of wetting exceeds the rate of drying, which is exactly what this picture shows. It's brilliant. First time I looked at it, I'm like, okay, Joe, go to the next slide. And then I started looking at it and going, that is exactly what building science is as it relates to wooden high-performance structures in a nutshell. Water comes in, water dries out. We do not have as good a drying capacity in high-performance homes. Why? Because they're airtight. When you make a structure airtight, the energy that used to leak out of your walls that you were paying for to heat that air, and it leaks out the walls, what did it do while it was going through the wall? It dried it out. You were paying for that drying capacity by heating the air and letting it leak out your building. It's incorrect for I'm going to say it, a SIP manufacturer to say their SIPs are less likely to have mold issues. That's ridiculous. Anybody that makes a high-performance airtight house has a higher potential for having a moisture issue because they don't have as much drying capacity. There's always going to be the capacity for moisture to get into a structure because people shower and they use water and they water their plants and what have you. It's life. There's moisture in homes. What we want to do is we want to get that moisture out of the home by increasing the drying capacity. In all things, I'm always thinking drying capacity. I might not think about it for very long if I'm building in Phoenix, but you can bet your bottom dollar I'm thinking about it if I'm building in Buffalo or Maine. Back-to-back ventilating. So here's a metal roof going over top of a SIP. What did we do? I don't remember where this job is. We put in furring strips and we did it in a herringbone fashion so when that water did leak through, it was able to drain out and get out from underneath that metal roofing. That's back ventilating at its best, right there, underneath that metal roofing. Question?
Isn't there adequate ventilation in the ridge?
There might be ventilation at the ridge if we were...
No, in the ridges of the standing seam.
In a traditional standing seam, no, there's nowhere near enough
In the bond side.
in Maine or Buffalo. It might be enough in Phoenix.
Okay.
It's all, I understand what you're saying.
Yeah.
So what I look at when I put a cladding on is the cladding self-ventilating?
Yeah.
What claddings are self-ventilating? If this metal roof was multi-crimped metal, you know, if it was a 5V crimp, you familiar with that term, 5V crimp? Okay, that's self-ventilating. Air's moving up through it all the time, right? Would I need the furring strips if I had a multi-crimp metal roof on it? No, I wouldn't. If I was putting on tile, self-ventilating. If I was putting on, what else? Tile, I can't think of them right now. Tile and cedar shingles are quite well ventilating. If we go to the siding, vinyl siding. Vinyl siding is the best and the worst siding in the world for those people who don't like vinyl siding because they think it's ugly. But by God, it'll certainly self-ventilate itself.
What about traditional shingles?
Traditional composite shingles,
They have shingles on that.
they don't self-ventilate. They will not self-ventilate if you take a shingle and attach it directly to your SIP. There's no air movement under the cladding.
What do you do for shingles? Can you use shingles on a
Oh, you certainly can. So depending upon where we're building, we might have to create a more robust ventilation. I use a mat, ventilation mats, Inca-Drain, Keen. They make a polypropylene woven mat that you lay down, and then you put your shingles right over top of that, you're good to go. Now, would I do that if I'm building in Phoenix? Hell no, I wouldn't do it, because I don't have enough wetting to be concerned. I only do it depending upon where I'm building, based on the cladding type that I've chosen and what the capacity for drying that I need to build into that system to create a nice, robust, durable structure. Question?
I was late to class, so I've got a question to get when you talk about the venting, are we talking about moisture that may leak up from the inside? Hot air comes up with moisture, gets caught up in the panel and gets out that way? Or are we talking about moisture, you've got everything sealed, moisture that may try to get in around flashings or?
It's an excellent question, and the answer, it could be either. We know there's no perfect installation, because if any of us have done blower door tests, right? We've done blower door tests. Have you ever seen a zero? Well, I never have. I've gotten close, and I was really proud of that, but it still wasn't perfect. There's still air moving somewhere. And so there's always that capacity for air to move through your assembly somewhere, and it might not be the SIPs. I might have done a perfect job in the SIPs, but guess what? The window installer was just like, windows, yeah, they leak eventually, right? And you get moisture.
There's not a situation where putting a SIP roof in, let's say, and you've got it all sealed up, you really want to strip it. You really want to strip the roof and vent it if you've got anything other than what you were talking about, self-ventilating.
Where are we building?
Well,
That's the, people call me all the time and they're like, hey, I'm doing this thing, and they're like, I can't answer it. That's why we don't go on the internet and get answers to stupid questions. No, I'm not saying you're stupid. It was a brilliant question. The follow-up question is always, where are you building?
southeastern.
I will give people a different answer in their details, whether they're building in West Virginia on top of the mountain or in the holler. Because in the holler, it's wet and shady in amongst the pin oaks, and they don't get any sun. But up on the top, they get wind and they get sun, and it dries out. And that difference between capacity of drying and capacity of wetting changes. Back ventilation is cheap insurance for good durability, and it does other things for us too. If we back ventilate, we also improve our STC number, because it's a further disassociation of the outside environment to the inside of the building, so your STC number goes up. You also add more air films because you got air layer in there, and more air films, if for anybody who's done energy modeling knows, it pumps up your performance because you get greater energy efficiency out of additional air layers. You'll also never see shingle ridging, because if you disassociate it from your panel and you get movement or anything like that, you'll never see it in something like a 3-tab composite shingle. Here's back ventilation on the side. This is in Minnesota, in fact. Yep, regular 30-pound felt, because it's great. It's a great rain screen. I shouldn't say it. It's a great drainage plane, and that drainage plane is in the rain screen or the back ventilation before it's furred off, and then the cladding goes on. Very robust drying. If you see shingle ridging, I can guarantee you that's not back ventilated. Why do we get shingle ridging? Because things move. And when things move and that movement causes a shingle to buckle, it happens. It's not always an indication that there is an installation issue. I've had projects that were done perfectly fine, and there was some amount of movement because acclimation of the wood caused some movement or tightening of the joint, and the shingle buckles. And it's usually very, very slight. It usually only happens on 1 or 2% of the projects that I see out there going up. And the vast majority of the time it dissipates, settles down, and relaxes after a year or so. Okay? But I guarantee you, if you had back ventilation in there, you'd never see it at all. So if we talk about the philosophy of tight structure, I think we could all agree that really airtight structures do some good things for us. They eliminate drafts, they cut down on noises, because we got that nice STC concern out there. It drops down on dust. I've had clients say that the SIP house they live in is the cleanest house they've ever lived in, because there's no dust in it. Because where does dust come from? Underneath the walls or through the cracks. And if you got a nice airtight house, it actually tends to be a cleaner house. So it also keeps out outdoor pollutants. So all those are good things, right? Well, what happens if we hired the HVAC contractor that forgot to put the V on the side of his van and said, ventilation, just go down to Home Depot and buy a fart fan. You'll be fine. You just hired a hack. All he's concerned about is heating and air conditioning and not the ventilation. The ventilation is how do we get fresh air into this building, because guess what? We built a tight house because we want tight structures because that makes a high performing structure. But we still need ventilation. We've got to get ventilation into the house to take care of things like poor indoor air quality or moisture problems or occupant health and sickness and concerns. SIP structures have been tested and shown to be upwards of 10, 15 times tighter than conventional construction. All right? We do it because we seal the joints. How do we seal the joints? We can use two-part foam. We can use a froth pack with a two-part injected foam into the joints. It fills it all up. Boom, we've got a solid foam condition. We use two-component foams. We use single-component foams where is appropriate. We also use a number of different types of mastics and tapes and gaskets. Depending upon the manufacturer that you're speaking to, they may have subtle differences in the specific materials or techniques that they use and recommend in their system. Okay? That's how we seal these things up, is to make them airtight. Now, if we've made this building airtight, and we know it's airtight, how do we address that ventilation standard? Well, we have to design this into it. Remember back at the beginning we said we were designing the engineering and the electrical chases and how are we going to make the panel joints. We also have to consider HVAC and the design of that system. It's incredibly important. If you're building the same structure time and time again, then do it once and do it really, really well and figure out what you need in order to make it work properly. Equipment sizing, incredibly important. Oversized equipment, short cycles, and causes moisture issues. I've had HVAC contractors literally cause the condensate problems or the moisture problems in the structure because of the way they designed the structure. And here's how they designed the structure. They got out of their truck and they went, it looks like 4 tons, I'll sell them 5. They went the wrong way, by the way, okay? And they don't appreciate the fact that a high-performing building might actually need a lot less air conditioning. In my area of the world in West Virginia, not to use rules of thumb in HVAC, but before I got into SIPs, we would typically be specifying, or HVAC contractors would typically specify 1 ton of air conditioning for about every 600 to 700 square feet of living space. That's a rule of thumb, okay? 1 ton per 600 or 700 square feet. Not too far off from a lot of areas of the country. In the projects that I've done over the last 20 years that have properly been designed with an HVAC calculation and determining loading, typically average in around 11 to 1,200 square feet per ton. That's a big difference, right? And when you put in too much tonnage, don't design your system right, you are putting more moisture into your house, or I should say you're not taking the moisture out because the air conditioning system is not designed properly. So you have to figure this out properly. It takes a contractor or a HERS rater or somebody in the energy calculation and modeling field that understands all of these things and how you do it properly. All right? You got to consider, where is your equipment stationed? Is it all inside of the conditioned space? How tight are we? Where's our supply and duct? How are we going to do ventilation makeup? Is it going to be a supply only? Is it going to be a supply only? Is it going to be a discharge only? Is it going to be a balanced system? There's different ways to do this to make it work. I love this slide because it's really old and it tells people something that they never even really thought about. How many people are allergic to their own house? This chart, developed back in the long time ago by ASHRAE, says all the good and bad things that happen when your structure moves out of the proper zone of humidity. Relative humidity in your house, really comfortable, right around 35 to 45%. Get too much, it gets wet and sticky and ugly. Gets too high, or it gets too high and it gets wet and sticky and ugly. It gets too low and your lips crack, your nose bleeds, and your furniture all gets loose because it shrinks, right? And the joints open up in your floors. The one thing I really like to show on this chart is dust mites. Dust mites do not drink water. They absorb moisture through air when the humidity is high enough, above 53%. 53% is really too high for good humidity in the house for comfortable living, but guess what else it does? If you keep it below that 53%, you don't have dust mites in your house. How many people are allergic to their own houses and don't even know it because of dust mites? A lot. Some of you may even know that they are a problem for yourself. Get your humidity below that point and all of a sudden you've solved a problem within your own structure. How do we test for airtightness? Blower door tests. How many people have done blower door tests? Fair number of you, right? It's pretty simple. We put a big fan in the doorway, we hook it to a computer, we blow all the air out of the structure until we get a negative pressure inside the building of about 50 pascals. Thank you, I lost myself for a second. 50 pascals of difference, which is about the equivalent of a 25-mile-an-hour wind blowing on all sides of your house. That's the pressure that you would see on that structure if you had 50 pascals differential pressure. Okay? If all of our duct space was inside the conditioned envelope, we don't need to do a duct blast test. We don't really care. I mean, we do care, but not as much how tight our ducts are because we're not worried about energy leaking outside of our conditioned space. And if we're using a entire SIP envelope and everything's inside that envelope, the duct blast test almost becomes obsolete. Okay? We want to find out how tight our structure are, and we want to do this twice. Once before we put drywall and covering so that we have the capacity or the ability to go in and fix areas that we find air leakage that it shouldn't be. It does us no good to build the house, finish it, paint it, get all your trim in it, call it done, and then call your HERS rater and say, hey, I need a blower door test because I'm trying to get this tax credit for tight houses and energy efficiency, and have them come over and do the test real quick and say, here's your number, bye, have a nice day, I'll take my $350. Wouldn't you be a whole lot better to do this while it's under construction? Question?
So then the question for volumetric modular builders such as us who build entire modules with cabinets, trim, windows, doors, everything in it, how do we address that if we're building with SIPs or even doing conventional construction? Because we're completely finished in segments out the door.
That's a good question. If your detailing is done in the factory and you have control and a quality control system that determines how those things are being done and all of those controls are being followed, then I'd suggest you're probably in a pretty good shape. But as soon as you start building that house and assembling it and sealing your joints in the field and installing your windows in the field and you don't have control over that, it is that blower door test that allows you to double check those errors. So your in-house QC program and doing it in the factory is your best. It
is, and the blower door test becomes the verification.
It does.
Of that.
Yes, blower door.
So basically what we're doing is we're building it correctly, and then the blower door test confirms that for us, and actually it does.
It does. So I take no issue with that philosophy of how you approach that. I think it's the right way to do it. So I'm just about wrapped up here. We're getting close. If we want a balanced ventilation system, you'll often hear the use of ERVs or HRVs, or a heat recovery ventilator or energy recovery ventilator. All it is 2 fans in a box and 4 holes in the side of your house, or 2 holes inside of your house. Fresh air comes in, puts fresh air into the house, stale air goes into the box and gets blown out, and in some cases those air paths mix magically to transfer heat and moisture so that we maintain a balanced system in our house. Remember, we don't have a leak in our structure unless we have 2 things. What are those 2 things? We need a hole, and what else do we need? Differential and pressure. You can put a hole in the side of your building, and if there's no differential and pressure, air's not going through it. You need the differential pressure, and you need a hole. These systems maintain balanced air pressures inside of your envelope. How to SIP? Question? Last slide. Last chance.
Yeah, so for that last, are you saying that those systems, even in the presence of a hole, will help you maintain equal pressure?
They will. Because
So
it creates, yeah, but don't think it's the magic answer, because guess what? You can get differential pressure when the wind blows, right? Windward, leeward side of your house, boom, you got differential pressure. And that ain't going to solve that.
Yeah.
But it will certainly help, especially when you have combustion appliances and things of that nature. That's where it really, really helps. Okay, how do SIPs compare in cost? Well, I don't know, they could be less, they could be more, they could be about the same. I have to ask that same question back to you, much like I asked the same question back to you about, well, where are you building? You asked me the question, how do they compare in cost? I have to ask, what metric do you want to achieve? How do you want to build? Do you want to build with no energy performance in mind? Do you want to build outhouses in West Virginia with pallets and tar paper? It's pretty cheap. I've seen it happen. Where are the cost of SIPs? Well, they're way up here. It's a whole lot cheaper to build outhouses in West Virginia with no energy performance. Oh, now you want to start complying with some energy performance? Start adding the layers of cost and labor for materials. You want to get up here to the Energy Star or Energy Star Plus. You want to start building with zero energy. You want to build passive house. SIPs do it. They did it for what you paid for it originally. They will perform at that level because I can get 0.6 air changes per hour at 50 Pascal with my SIP envelope. And I'm not doing anything special. I'm just following the installation manual. You want to do that with stick framing? Okay, and hit passive house standards? It's going to cost you more. So where does it compare in cost? It compares in terms of where you want that performance metric to land. That's my answer in cost. Question? I'm back to you, Jack.
I've got one real quick.
Okay.
So if you've got a moisture issue, you thought you did everything right with your panels on your roof, but something happened, moisture got in, what's your repair look like?
Oh, okay, that's a good question. Repairing SIPs. And I've seen all kinds. I mean, I've seen everything from going in where the repair was from a tree limb hitting a roof and jamming a limb right through the garage roof. And we went in and we patched it up and foamed it and walked away and it was done. And I've seen projects where it was done so poorly that they literally had to remove the panels off of the roof and replace them because they had completely deteriorated from improper design and or installation. You can always look at a SIP that independently of the rest of the roof needs replacing. It can always be taken out and replaced. It can be done. Similarly to that, people would ask a question like you just asked, but also, well, what if I want to make changes? What if I want to add a window or add a door, things like that in the field? I personally think it's a lot easier because of the strength of a SIP. I can go in and do things with it by cutting a hole in it and doing some quick engineering and determine, you know what, I don't need to go in there and add a bunch of jacks and a bunch of headers and things of that nature. I can put another doorway right in the middle of that wall by simply cutting the opening, and I know that the panel above it is capable of handling the engineering or the loading, the actual loading above it. So I think, to me, it's I would say easier. There have been times where I really regretted having to tell a homeowner that we were going to have to take the panels off of their roof because somebody 25 years ago screwed up bad, and it's a bad situation. Yeah.
Are SIPs easy to cantilever?
They are, and they're very strong, and I've done cantilevers with SIPs upwards of 6 to 8 feet
How thick?
thick.
Like foot thick?
Yeah, like 12 inches thick, and probably had some lumber in it as well. But yes, I can get some significant cantilevers. Not in 200-mile-an-hour wind zones, but I can get some pretty good cantilevers. Question?
What about the sustainability carbon footprint case for SIPs and potential more sustainable substitutes?
So the environmental life cycle analysis of SIPs have been done. SIPA has paid for it.
There's one on the website.
Yeah, there's one on the website, and it talks about what is the tipping point of the carbon footprint to manufacture the panel and to build a SIP house versus when is it now better for the environment because of all the energy we saved. People who want to talk to me about, well, it's got foam in it and foam comes from petroleum products and therefore it's bad. And it's just kind of that, black or white, it's bad, it's oil. And I would respond by saying, yes, it is. It uses petroleum to create foam to make a very fast producing, energy high performing system that saves more oil over the life of the structure or more fossil fuel over the life of the structure. It's a tipping point, If you want to build a building that's only going to be up for 2 years, go build it out something else. You want to build something up to live in that's comfortable and is going to perform well and save those fossil fuels or those environmental concerns for the life of the structure, then it really does start to make sense.
So if we can, let's transition. I'm going to wrap up with some resources and where we can find some more information. And then if there's some detailed questions, because I'm between you and lunch at noon, so we have 4 minutes. So
Sorry.
no, it's okay. So real quickly, And the point of being here live is to ask the questions. You can see these PowerPoint slides and all these other resources on the website. The real value here is having an expert with 30 years of knowledge comparing and contrasting. So I think you kind of understand why we feel panelized construction makes sense, depending on where you are, depending on what you're building and your economics are for labor. Additionally, as we just kind of go past here, there's a tool. It's called this SIP True Cost Building Tool, and this is what Sam Rashkin and I and a variety of different high-performance builders have put together. It's an Excel spreadsheet. It's an eye chart. You can't see it here. But essentially what it does is it just says, hey, and it's iterative. You enter in your data up here and you say, how big am I building? What are my average costs? If I'm going to build it on a traditional framing versus SIPs, and you can go line item by line item, down the sheathing, down the carpentry, down all of the various buckets where you typically track costs, HVAC and so forth. And it'll compare the hard costs versus method A versus method B. Additionally, though, that's only part of it. That's this kind of money saved, cost saved, and then there's the value add piece. So what are the additional value of having a really quiet home? What are the additional value of being able to control the humidity? So, little Bobby that has asthma can breathe better. What is the value of maybe not having a basement and moving that square footage up into what used to be an attic, but now it's conditioned space. So maybe it's worth $200 a square foot instead of $100 a square foot down below in the basement. So how do we tell somebody SIPs don't cost more? Well, it just depends. And it depends. So this tool, we've developed it. It's in its beta phase. So this particular example here, we took Gene Meyer at Thrive Homes in Colorado, in the Denver area, only builds zero energy homes. And he uses a double stud wall scenario. And so we said, Gene, it's expensive, it's laborious. We think you can get there cheaper with SIPs. So we actually took his design and we said, hey, hard costs, installed costs, which the builder is paying, we can save you $13,000 in this particular iteration. Additionally, we feel like we're creating $13,000 more of added value for a total of $26,000. So you can go through and you can change the items and say, no, I'm not going to save money on my insurance, or hey, I'm going to save money because the walls are true and straight, and I'm not going to have to shim things when I'm putting in the cabinets, things like that. So it's different for every builder. So this kind of tool allows you to play with the numbers, and you don't have to believe us. You can work with your SIP manufacturer. You can actually get this and download it online to play with. Additionally, the Trade Association's been here since 1990. It's really about education and transparency and just helping people understand that you can trust SIPs. There's a lot of great studies that are on the website. One thing I will say, in the project showcase, there's over 600 showcase maps with very detailed studies of Holiday Inn Expresses, Marriott courtyards, 4-level apartment buildings, passive house buildings. You can search it by blower door test, indoor air quality issues. You can search it by HERS rating. So take a look and you can actually see whether it's a school or a lot of different variety of things to see. The little magazine or the brochure that I passed out, it's actually one of two. We brought Building with SIPs, What You Need to Know. It actually hopefully takes the 10 buckets and answers your question. If you're actually designing it up front, there's another one called Designing with SIPs, Design Considerations. So additionally, we've taken those 10 steps in both of those, and we've kind of done a deep dive and created a series of what we call high performance building envelope, like chapters with each particular background for you to really get into the nuts and the details if you're interested in that. So these kind of best practices kind of go beyond just the checklist. So if you really want to do some homework, you can do those. Additionally, if you haven't gotten enough of Al Cobb here, he actually has done 10 chapters of what we call our Building Education with SIPs Training, BEST, the best program. And so they're on YouTube, they're on our website, they're AIA certified if you want to get CEU credits. but they kind of step through logically the whole process. You can even take a test after each one, and after you do the 10 chapters and pass the 10 tests, you can become a registered builder, a registered SIP builder. Then once you actually build a structure, blower door test it, and show that you can meet the performance criteria, then you can become a master builder, if that credential is important to you. So great new website, it just launched, sips.org, SIPS, Structural Insulated Panel, sips, plural.org. If you want one-stop shopping, you can just go on the design professionals thing. There's a whole set of data there just for you, the builders or owners, or gobs of different sources, or if you want to look at those 600 projects that I was talking about. So I won't go further there. If you didn't take a picture of our email addresses and you want to get a hold of us, on the first slide you can have it here again, or you can go on the website for the Trade Association for Devon's Summit and download a couple of these brochures. I also have the Excel spreadsheet that you can download, that true cost bidding tool, or you can go to sips.org. So with that in mind, I think, did I do it? 12:02, sorry.
I think Jack and I are both leaving out of here today, so I will be around throughout lunch. I'd be happy to take any questions, hand a business card, or talk to you about anything
Will you be
specific.
making this available on your website, this
Yeah.
presentation at all?
Yes, it is.
The whole thing?
Yes.
So we've taped it, we've recorded it. All of this information already exists on the website. It's just we've fed you through a fire hose
Sorry about that.
in an hour and a half. You can get them individually chapter-based on the website through that Building Education with SIPS training program. So thank you, everybody.